your screen. It was great.
Great, wonderful. Thank you for having me today. I'm sorry I don't have a camera on me today, so you'll just have to look at my name instead. I am Jennifer Andreas. I'm with Washington State University Extension, and I run the Integrated Weed Control Project. Just to give you an idea of what the overall program role is, it is a statewide program, and we provide biocontrol agents to land managers and landowners. So essentially, if you have appropriate weed sites, we can work with you to get you biocontrol agents. We also provide education to land managers. So I do a lot of presentations, and I'll talk about some additional resources at the end of my presentation. One of the things I like to, as part of my program, is that we provide expertise and on-site recommendations. So if you're not sure whether biocontrol is a good fit for your weed sites and you want to talk about whether it fits into your integrated weed management program, I'm always happy to have those discussions and figure out what works. I'm involved in actually a lot of different things. I'm involved in several different research projects. I won't be able to get into them today. I'll talk a little bit about the knotweed one. This program receives substantial funding as grants and contracts, and has really run that based off of grants and contracts. And the Forest Service is our primary funder, but we receive both state and federal funds, as well as county noxious weed funds. In the past, I have received funding from the Colville Confederated Tribes, the BIA, and Kalispel Tribe. So I thought it would be helpful. Wendell and Jason have both talked a little bit about biocontrol, but I think it's helpful to just define what that is. We're all on the same page. And that's the intentional use of one living organism to control or suppress another. So in this case, we're controlling noxious weeds through my program, and that can be done with insects, pathogens, mites, and we almost never use nematodes. The type of biocontrol that we are using is called classical biocontrol, and this is different from other kinds of biocontrol because it's based off a theory that describes why our non-native plants are so good at invading and outcompeting our native plants. And that theory is called the enemy release hypothesis. So it's suggesting that the reason that our non-native plants are so good when they are introduced into a new region is because they come here without any of their natural enemies. And so this really allows them to expand into large numbers and outcompete native species, which do have a lot of natural enemies. So with classical biocontrol, what we do is go back to where the plant is native to, and we look at what's attacking it there. And after a lot of testing to make sure that it won't attack any native plants or economically valuable plants, we bring it into the introduced range. And the goal is to restore the balance that you see in the plant's native range. So there's lots more detail to that, and I'm always happy to talk about the environmental safety of biocontrol. It's just I don't have time to do that today. So I've been fortunate to work with a number of tribal partners within the state of Washington. Those are starred with red stars, and we've worked on a number of different invasive plants within those regions. I thought I'd start today with a real success story of my work with the Colville Confederated Tribes. Like many other regions, the Colville Confederated Tribal lands have undergone some pretty serious wildfires in the last few years. And although the weeds tend to do very, very well after a fire, oftentimes the biocontrol agents can be wiped out. And so we do need to, at that time, go in and reestablish biocontrol agents that were there. So you can see in this top photo, this is a fire that was called the Tonk Block Fire in 2015. And just to give you a sense of what weed populations can look like after, this is what it looked like after in 2016. So Dalmatian toadflax comes in like crazy after a fire. Fortunately, we have a really great biocontrol agent for toadflax, and Wendell talked about that. It's a stem mining weevil, Messina cyanthiniformis. It's probably one of our most successful biocontrol agents, and it's widely distributed across the state. So if you have toadflax and you haven't had a fire recently, you very likely have these beetles already present. So this is a different fire that occurred on the Colville tribal land. It's called near Elmer City. And after the fire in 2016, hundreds of acres of Dalmatian toadflax resurged, and there were no biocontrol agents present. The tribe was really unable to control this with other methods because the landscape is really challenging to work in. It's extremely cost prohibitive to try and manage this with other means like herbicides. And also there just weren't the contractors willing to do the work within the region. So we set up some monitoring plots, and I'll show you the data, but this photo series shows you how extensive that population looked like in 2017, the year after the fire, and how we've been able to see changes in the population because of our biocontrol agents. And I think that's even better demonstrated when you look at the actual data that we're collecting at sites year after year. So down here in 2017, we had no insects present at the site, but you can see that our plants were really robust. They were very tall, and we also had a lot of stems per quadrat. And very quickly, their populations built up after a release. And so as the insect populations have increased, you'll notice that both the size of the plants as well as the number of plants within quadrats was dramatically reduced. So even though the plants are still present, they're really just not at that economically damaging level anymore. And that's really our goal with biocontrol is the plants will be present, but they're just not creating the same problems that they used to. So ultimately at this site, we saw some really wonderful long-term impacts and successes. We saw that there was increased forage, increased wildlife habitat. Our native species started coming back, and also some culturally important plants, which is a real success story and wonderful to see out in the field. Now, this is a list of all of the weeds that have biocontrol agents, and obviously I don't have time to talk about them today, but I'll just quickly run through two that I'm really excited about. And there's lots going on, and if you're interested in biocontrol, please reach out to me because we do have a lot of new things happening that you might want to be involved in. The first one I'll talk about briefly is Russian knapweed. This is a species that's found primarily, exclusively, I should say, really in eastern Washington. Very widespread across eastern Washington and very challenging to control. You can see in this top right corner, it basically can create a monoculture. And we have two biocontrol agents that we've been releasing since about 2012. The first one on the right is Yapiella bonacovi. This is a gall midge, and it creates these shoots on the plant. I would consider it the less successful biocontrol agent because it does require a constant water source for the populations to build up. What I'm more excited about is the gall wasp. This is Alicidia croptolonica. It is what you're looking at on the left, and it can create galls all over the plant. And what we are seeing is the plants are stunted and they're unable to flower and they're just not as robust. So we have some preliminary data that's looking really nice, and I'm excited to see where this goes. So you can see in 2014, we did our first release. This is the Yapiella. But again, those populations just don't build up like we want unless there's a lot of water present. In 2017, we released the gall wasp, and their populations can increase really dramatically. So you can see the populations of Russian knapweed are pretty consistent in terms of their height and also the number of stems per quadrat. But we are starting to see them trending down as our biocontrol agents are rapidly increasing. And so I look forward to the next few years to see what happens at these sites. Another project that I've been involved in and doing a lot of work on is the knotweed project. And this is a species that impacts a lot of Western Washington, as you can see in these maps. In Washington, there's three different knotweed species, but in Washington, we primarily have giant knotweed and the hybrid knotweed. We don't have that much Japanese knotweed. And there's a new biocontrol agent that was approved in 2020 called Aphilaria itidori. This is a sap-sucking psyllid, and so you can see what it looks like. It's extremely tiny. And there are two different strains, one that attacks the Japanese and hybrid strain, which we call the southern strain, and one that attacks giant knotweed, which is the northern strain. And we are excited that we believe we'll have the Murakami strain soon, which looks like it might have better impact. So in 2020, we began rearing this in the greenhouse in Puyallup. That's where I'm based out of. And all of this funding was provided by APHIS and Washington State Department of Agriculture. So I'm really grateful that we are able to move this project forward because of that funding. So we began doing mass releases in 2020. through 2022. Right now, we have 17 release sites, 9 are on giant and 8 are on hybrid. And you can see with the bottom pictures, this is just some different strategies we're using for how to get the insects out on the ground. So we release them free so they can just go where they want. We put them in sleeve plants, and we also put out potted plants. This will give you an idea of where our current releases are. So we have a lot of giant knotweed out on the coast. This is in the Hump Tulips River. Sorry, just forgot the name of the river. This is the Hump Tulips, but we also have other populations in other areas. And then so that's in red star is the giant, and then the yellow is our hybrid site. So after we release, we collect a lot of data. We're looking for the insectonology. We're looking to find the insects, which can be quite challenging. We're looking for any damage. You can see in the middle photos, this is the damage that the northern strain will do to giant knotweed. So these are secondary shoots, but this is a great indicator that the psyllids are present because they do this twisted up gnarling of the plant. We also are collecting plant data. So we're looking at, the goal is to understand what did the knotweed populations look like before we did the release, and what do they look like after. And so we collect data on the plants as well.
About 4 minutes left, Jennifer.
Okay, thank you. So I won't go into too much detail about what we're finding in terms of specific sites, but I can say that it's been a really challenging program. The plants, as you know, knotweed plants are massive, and we're working on an extremely tiny insect. And so oftentimes the plants are too tall for us to see the very tops of them. And so if the insects are there, they can be hard for us to note. So we're doing a lot of releases. We're putting out insects, we're repeating releases at the same sites, and our recovery of those insects has been pretty poor. Typically, we're finding maybe 1 to about 7 psyllids at a site when we go back. So we're hoping that that will increase as the more we put out on the landscape. And so I think this is pretty typical for the knotweed programs across North America and even in Europe. So we're just trying to understand how best to make this a successful program. And it is early days. And so we always know that in early releases, it takes a while for us to understand what's happening. The last thing I wanted to talk about really quickly was biocontrol resources. So we're working on creating more and more information for people to have access to general biocontrol information. We've been creating biocontrol fact sheets through the North American Invasive Species Management Association. These fact sheets are free, and I put a QR code in the corner here. And ultimately what we'll have is fact sheets for all the weed species we have biocontrol agents available, and biocontrol agent fact sheets. So ultimately, for all of North America, we will have 40 different systems. Right now we're at about 26. So I would encourage you to check back, look for fact sheets and see if any of that is useful to you. We also hold a summit every year where we provide biocontrol information, and that is done in December. And you can find those on YouTube, on the NIUSMA channel on YouTube for past summits. We're also working on building out ibiocontrol.org. This is already a good site in terms of resources for monitoring and other additional information publications that you're looking for on biocontrol. But we hope to have this by the end of the year be a really robust site for kind of a clearinghouse for all things weed biocontrol. And I'm not associated with these weed and biocontrol videos, but this is a new series that has come out. Rachel Winston has created these videos that are on both weed biocontrol and also weed identification. So if you just Google biocontrol, YouTube, University of Idaho, that's how I get to it really quickly. You can find these fairly short videos that provide a lot of great information on both biocontrol and weeds. So I would really encourage you to have a look at that. And especially as you bring new staff on, you may find that that's a really helpful training tool. This is my contact information. I do have a website. I will apologize, it's quite out of date. I've been wanting to update and get a new one up there, but it does still have some good information. You're always welcome to email me or reach me on my cell phone, either through phone call or text. And I do apologize that I will have to leave after this presentation. So if you're interested in working with me and figuring out if biocontrol is a good tool for you, or you have questions generally about biocontrol and whether it's safe or whether it feels like a good management strategy, I'm always open to have those conversations. So with that, I will stop sharing and thank you very much for your time.